Welcome to P.U.R.E. Physics. Today we're going to see an important topic called as equations of motion under gravity of class 11th. This is a common topic for CBSE and Tamil Nadu syllabus. So moving on to the topic. So before entering into this derivation, we need to know the three kinematic equations of uniformly accelerated motion that was derived using calculus method, and that derivation will be given in the description link. So please go to that video and learn the topic, and then come under this derivation so that it will be clear for you to understand the concept clearly. So I'm going to take these three equations. Actually, there are four equations, but three equations are necessary here. So this is my equation 1, and equation 2, and equation 3. So now let me go on to a diagrammatic explanation. Consider a ball. Consider a ball which is being thrown from a cliff. So this is a cliff. The ball is being thrown from a cliff, and it travels a distance of height. It travels a distance of height h. And let me take the traveling path as positive y axis and the horizontal direction as positive x axis. Why am I taking the downward direction as positive y axis? Anyhow, generally in a graph, the axis that goes from 0 is called as positive y axis, and the axis that goes below the origin vertically is called negative y axis. But now, since I'm going to deal with gravity, I'm going to take the axis below origin as positive y axis, because the gravity is always acting downward to the surface of the earth, and the ball is also traveling downward towards the surface of the earth. Therefore, it is not opposing the gravitational force. That is why I take gravity as positive gravity, because it is going along with the gravitational force. If my ball is being thrown upward, then my y-axis will be directing upwards, and it will be opposing the gravitational force. In that case, we will take the acceleration as minus g, because it is opposing the gravitational force if it is thrown up. But in this case, the ball is being thrown downwards, where it goes along with the gravitational force. Hence, my y-axis will be positive, and the acceleration due to gravity will always be g. And we need to know that the acceleration due to gravity near the surface of the earth is always a constant. So now we are going to consider this diagram. Now here, since the ball is moving in the vertical downward direction, there will be no acceleration in the horizontal direction. Since the ball is only moving in the downward vertical direction, there will be acceleration only in the y component, and there will be no acceleration in the x component as well as in the z component when I speak with respect to coordination, Cartesian coordinate system. So now I'm going to find the acceleration vector. Acceleration vector here is positive g j cap. What this j cap represent? J cap is the unit vector for y axis or y coordinate. So now from this I can say, from this I can relate. So in your derivation you should not write I or something like that. We need to write, from this we can relate that acceleration in x component is equal to 0, acceleration in y component is equal to plus g, acceleration in z component is equal to 0. So these are the three conditions that is necessary in this derivation, and that too the second condition is most important, where we will use in all these three equations. Now I'm going to substitute this ay is equal to g in every value of a in all these three equations. So let me rewrite this first, second, third equation. The first equation can be written as v is equal to u plus a by t. The second equation can be written as y is equal to ut plus half a by t. I'm gonna go with the respective of y coordinate system or y component. So third equation becomes v square is equal to u square plus 2ays. And here you need to know that h is always equal to y, which is always equal to s. Why am I taking this condition? Because the height is also equal to the y-axis or y direction, and which is also equal to s. S is nothing but the position, so the distance. So in the place of s we can substitute y, or in the place of y we can substitute h, or in the place of s and y I can substitute h, which will be useful in later part of the derivation. So now I have written these three equations in terms of ay. Now I need to substitute this ay in this place. But before moving on to that, let me assume that this ball is being thrown with an initial velocity u. This ball is being thrown with an initial velocity u. Okay. So what is this initial velocity? In order to throw the ball, you are going to apply some force, right? You will take the ball and you will throw it with some speed. So that starting speed is called as initial velocity. So I'll write let u be initial velocity of the ball. Okay. Now you need to find the velocity and displacement we need to find the velocity and the position of the ball at a particular time period t. So we need to find the velocity and position of the ball at time t. Therefore I am going to replace ay with g. So the first equation will become v is equal to u plus gt, and my second equation will become, in the place of a I am going to substitute g. So here the acceleration is equal to g. Acceleration of the ball is equal to acceleration due to gravity, because the ball is being moving in the vertical downward direction acting along the gravitational force. So the gravitational force will make the ball to move downward. So therefore I am going to write a is equal to plus g, and the second equation becomes y is equal to ut plus half gt square, and the third equation becomes v square is equal to u square plus 2gs. So keep this new equation and mark these equations as 4, 5 and 6. Now I'm going to assume another condition, that is when the ball is being thrown, when the ball is thrown from rest. What do you mean by this statement? When the ball is thrown from rest means the initial velocity of the ball is 0. Here the initial velocity of the ball is 0. That is the meaning of the sentence. So when you throw a ball from rest, that the initial velocity of the ball will be 0. So now you need to substitute u is equal to 0 in 4, 5 and 6. Therefore, your fourth equation will be v is equal to gt. When you substitute 0 in the place of u, you will get v is equal to gt. When you substitute u is equal to 0 in the equation 5, you will get y is equal to u into t. When you multiply 0 into t is 0. So therefore the ut term vanishes and you will be left with 1 by 2 gt square. And in the sixth equation, you are going to write u is equal to 0 in the place of u square. Therefore you will get v square is equal to 2gs. The u square term will vanish since applying 0 in the place of u will give you 0. So this will be my next set of three equation. This is equation number 7, this is equation number 8, and this is equation number 9. Now, now what happens? Now I need to find the equation relating the height and the time taken and the speed of the ball at a particular time t. So I need to find another set of three equations, that is the equation relating the height and the equation relating the time, and I need to find the equation for the speed of the ball at a particular time t. So I'm gonna use these three equations again. I'll erase this diagram. So in order to find the height, the equation related or relating the height. So what can I write? When you write the equation relating the height, you need to take two conditions. That is, the small t will be replaced with capital T. That is, the total time taken by the ball to reach the ground. And the height will always be replaced with h. H is equal to y is equal to s. So that condition, when I taught you while drawing the diagram, now you have to apply that concept. So you're gonna find the equation relating the height. So this involves the distance. So you're gonna use the equation which has distance as well as the time. So you will substitute these two conditions in eighth equation. So my eighth equation will become in the place of y I can substitute h. H is equal to 1 by 2 g into t square. In the place of small t, I'm going to replace it with capital T. So therefore, h is equal to 1 by 2 g t square. So this is my equation relating the height of the path of the ball. Now, or height of the cliff till the ground. Now I need to find the equation relating time. So this will be my equation 9. So now I'm going to use the equation 9, rearrange it, and then arrive at the equation for time. So therefore, I'll keep my t square in the right hand side. Therefore, t square is equal to, I'll bring this 2 and g, 1 by 2 and g in the left hand side, or transpose it. Therefore, I'll get 2h by g. Now when I take square root, I'll be left with t is equal to root over 2h by g. So this is my condition for time. T is equal to root over 2h by g. Now I need to find the equation relating the speed of the ball traveling in a particular time. So I'll erase this side. So in order to get the equation relating the speed of the ball, so equation relating speed of the ball in a particular time, will be, you're gonna use the equation v square is equal to 2gs, because it does not involve the time but it involves the speed and the distance. Therefore, my ball is moving in a distance of h. It is traveling a distance of h or height h, and I need to find the v square. So in the nature of this equation itself, I can find the speed of the ball traveling in a particular time t within a given height h. So my equation ninth equation will be, if this is ninth equation, this equation will become 10. So this will be my 10th equation, and this will be my 11th equation. And now, in order to find this equation, I'm going to use this ninth equation. So ninth equation will become as v square is equal to 2gs. So in the place of s, I'm going to substitute h. V square is equal to 2gs. So v square becomes 2gh. And now I'm going to take square root of this. So when I take square root of v square, I'll be left with v, which is equal to root over 2gh. Okay. So from this equation, from this 11th equation, I can conclude that as height increases, time also increases. As height decreases, time also decreases. So therefore I can say time is directly proportional to square root of height, and time is inversely proportional to square root of g. So a clear thing about this inversely proportional. So when you say time is inversely proportional to square root of g, you should not say time is inversely proportional to root over 1 by g, because like I said, if let me take that square root out of the thing right now. If I say t is directly proportional to 1 by g, this gives us the meaning same as time is inversely proportional to gravity. But if we say time is inversely proportional to 1 by g, then it will be giving the meaning of directly proportional. So whenever we write 1 by g, inversely proportional, if we say inversely proportional and if the second term has reciprocal of the quantity, then you must always say the quantity is inversely proportional to the quantity name, not the reciprocal of that quantity. So here you will say T is inversely proportional to gravity and not T is inversely proportional to 1 by g. Now when we write root over 1 by g, you will say T is inversely proportional to square root of gravity, or T is directly proportional to square root of 1 by g. So this is how you will pronounce, and you need to write the statement. So again I'll repeat, the time is directly proportional to the square root of the height, and the time is inversely proportional to square root of gravity. So this will be my conditions from equation 9. And this equation here, consider that if the equation for motion of the body, which is falling from a small altitude, that is, it is falling to the surface of the earth from the space, and the height of the falling body is much less than the radius of the earth. If my height is far less than the radius of the earth, then the body is said to be in free fall. So that is why we say that when the height of the particle falling below to the surface of the earth, if it is small than the radius of the earth, then we say the body's motion is called as free fall, which we learnt in the 10th standard of Tamil Nadu syllabus, first chapter, what is free fall, and we will also learn in this 11th standard also. So in the next class we will see another important topic. So till then, thank you.